Indian Space Research Organisation.
Coordinates: 12 deg 580 n 77 deg 340 e/12.96667 deg n 77.56667 deg e/12.96667 77.56667. The Indian Space Research Organisation, ISRO/ISROU/ Hindi: Bhartiya Antariksh Anus and Dhansngttn Parata Antariksa and Usandana Sangadhana, is the primary space agency of India. ISRO is amongst the largest government space agencies in the world. Its primary objective is to advance space technology and use its applications for national benefit. Established in 1969, ISRO superseded the erstwhile Indian National Committee for Space Research, INCOSPA. Headquartered in Bangalore, ISRO is under the administrative control of the Department of Space, Government of India. Since its establishment, ISRO has achieved numerous milestones. It built India's first satellite, Aryabhata, which was launched by the Soviet Union on April 19 in 1975. In 1980, Roni became the first satellite to be placed in orbit by an Indian-made launch vehicle, SLV-3. ISRO subsequently developed two other rockets, the Polar Satellite Launch Vehicle, PSLV, for launching satellites into polar orbits, and the Geosynchronous Satellite Launch Vehicle, GSLV, for placing satellites into geostationary orbits. These rockets have launched numerous communications satellites and Earth observation satellite. On October 22 in 2008, Chandrayaan-1, India sent its first mission to the Moon. Over the years, ISRO has conducted a variety of operations for both Indian and foreign clients. ISRO's satellite launch capability is mostly provided by indigenous launch vehicles and launch sites. In 2008, ISRO successfully launched its first lunar probe, Chandrayaan-1, while future plans include indigenous development of GSLV, manned space missions, further lunar exploration, Mars exploration and interplanetary probes. ISRO has several field installations as assets, and cooperates with the international community as a part of several bilateral and multilateral agreements. November 5, 2013, ISRO launched its Mars Orbiter mission, which is currently en route to Mars.
Formative years.
Modern space research in India is most visibly traced to the 1920s, when the scientist S.K. Mitra conducted a series of experiments leading to the sounding of the ionosphere by application of ground-based radio methods in Calcutta. Later, Indian scientists like C.V. Raman and Minard Saha contributed to scientific principles applicable in space sciences. However, it was the period after 1945 which saw important developments being made in coordinated space research in India. Organised space research in India was spearheaded by two scientists, Vikram Sarabhai, founder of the Physical Research Laboratory at Ahmedabad, and Homi Bhabha, who had played a role in the establishment of the Tata Institute of Fundamental Research in 1945. Initial experiments in space sciences included the study of cosmic radiation, high-altitude and airborne testing of instruments, deep underground experimentation at the Kola mines, one of the deepest mining sites in the world, and studies of the upper atmosphere. Studies were carried out at research laboratories, universities, and independent locations. In 1950, the Department of Atomic Energy was founded with Homi Bhabha as its secretary. The department provided funding for space research throughout India. During this time, tests continued on aspects of meteorology and the Earth's magnetic field, a topic which was being studied in India since the establishment of the observatory at Colaba in 1823. In 1954, the Uttar Pradesh State Observatory was established at the foothills of the Himalayas. The Rangpur Observatory was set up in 1957 at Osmania University, Hyderabad. Both these facilities enjoyed the technical support and scientific cooperation of the United States of America. Space research was further encouraged by the technically inclined Prime Minister of India, Jawaharlal Nehru. In 1957, the Soviet Union successfully launched Sputnik and opened up possibilities for the rest of the world to conduct a space launch. INCOSPA was founded in 1962 with Vikram Sarabhai as its chairman.
Goals and objectives.
The prime objective of ISRO is to develop space technology and its application to various national tasks. The Indian space program was driven by the vision of Dr. Vikram Sarabhai, considered the father of Indian space program. As he said in 1969. As the former Indian President Dr. APJ Abdul Kalam said, India's economic progress has made its space program more visible and active as the country aims for greater self-reliance in space technology. Hennock etc. hold that India also connects space exploration to national prestige, further stating, this year India has launched 11 satellites, including 9 from other countries, and it became the first nation to launch 10 satellites on one rocket. ISRO has successfully put into operation 2 major satellite systems, namely Indian National Satellites, INSAT, for communication services, and Indian Remote Sensing, IRS, satellites for management of natural resources. ISRO has also developed the PSLV for launching IRS type of satellites and GSLV for launching INSAT type of satellites. On July 2012, the former president, Dr. APJ Abdul Kalam said that research was being done by ISRO and DRDO for developing cost reduction technologies for access to space.
Launch vehicle fleet.
During the 1960s and 1970s, India initiated its own launch vehicle program owing to geopolitical and economic considerations. In the 1960s-1970s, the country successfully developed a sounding rockets program, and by the 1980s, research had yielded the Satellite Launch Vehicle 3 and the more advanced Augmented Satellite Launch Vehicle, ASLV, complete with operational supporting infrastructure. ISRO further applied its energies to the advancement of launch vehicle technology, resulting in the creation of PSLV and GSLV technologies.
Satellite Launch Vehicle SLV.
The Satellite Launch Vehicle, usually known by its abbreviation SLV or SLV-3, was a 4-stage solid-fuel light launcher. It was intended to reach a height of 500 kilometers and carry a payload of 40 kilograms. Its first launch took place in 1979 with 2 more in each subsequent year, and the final launch in 1983. Only 2 of its 4 test flights were successful.
Augmented Satellite Launch Vehicle ASLV.
The Augmented Satellite Launch Vehicle, usually known by its abbreviation ASLV, was a 5-stage solid propellant rocket with the capability of placing a 150 kg satellite into LEO. This project was started by the ISRO during the early 1980s to develop technologies needed for a payload to be placed into a geostationary orbit. Its design was based on Satellite Launch Vehicle. The first launch test was held in 1987, and after that 3 others followed in 1988, 1992 and 1994, out of which only 2 were successful, before it was decommissioned.
Polar Satellite Launch Vehicle PSLV.
The Polar Satellite Launch Vehicle, usually known by its abbreviation PSLV, is an expendable launch system developed to allow India to launch its Indian Remote Sensing, IRS, satellites into sun-synchronous orbits, a service that was, until the advent of the PSLV, commercially viable only from Russia. PSLV can also launch small satellites into geostationary transfer orbit, GTO. The reliability and versatility of the PSLV is proven by the fact that it has launched 65 satellites/spacecraft, 30 Indian and 35 foreign satellites, into a variety of orbits so far. In April 2008, it successfully launched 10 satellites at once, breaking a world record held by Russia. On November 5, 2013, the PSLV flew its 24th consecutive successful launch mission. Its only failure in 25 flights was its maiden voyage in September 1993, providing the rocket with a 96% success rate.
Geosynchronous Satellite Launch Vehicle GSLV.
The Geosynchronous Satellite Launch Vehicle, usually known by its abbreviation GSLV, is an expendable launch system developed to enable India to launch its INSAT-type satellites into geostationary orbit and to make India less dependent on foreign rockets. At present, it is ISRO's heaviest satellite launch vehicle and is capable of putting a total payload of up to 5 tons to low Earth orbit. The vehicle is built by India with a cryogenic engine purchased from Russia while the ISRO develops its own engine program. In a setback for ISRO, the attempt to launch the GSLV F-06 carrying GSAT-5P, failed on December 25, 2010. The initial evaluation implies that loss of control for the strap-on boosters caused the rocket to veer from its intended flight path, forcing a programmed detonation. 64 seconds into the first stage of flight, the rocket began to break up due to the acute angle of attack. The body housing the third stage, the cryogenic stage, incurred structural damage, forcing the range safety team to initiate a programmed detonation of the rocket. On January 5, 2014, GSLV D5 successfully launched GSAT-14 into intended orbit. This also marked first successful flight using indigenous cryogenic engine, making India sixth country in the world to have this technology.
Geosynchronous Satellite Launch Vehicle Mark E GSLV 3rd.
The Geosynchronous Satellite Launch Vehicle Mark II is a launch vehicle currently under development by the Indian Space Research Organisation. It is intended to launch heavy satellites into geostationary orbit, and will allow India to become less dependent on foreign rockets for heavy lifting. The rocket, though the technological successor to the GSLV, however is not derived from its predecessor.
Earth Observation and Communication Satellites.
India's first satellite, the Aryabhata, was launched by the Soviet Union on April 19, 1975 from Kapustin Yar using a Cosmos 3M launch vehicle. This was followed by the Roni series of experimental satellites which were built and launched indigenously. At present, ISRO operates a large number of Earth observation satellites.
The INSAT series.
INSAT, Indian National Satellite System, is a series of multi-purpose geostationary satellites launched by ISRO to satisfy the telecommunications, broadcasting, meteorology and search and rescue needs of India. Commissioned in 1983, INSAT is the largest domestic communications system in the Asia-Pacific region. It is a joint venture of the Department of Space, Department of Telecommunications, India Meteorological Department, All India Radio and Doordarshan. The overall coordination and management of INSAT's system rests with the Secretary-level INSAT Coordination Committee.
The IRS series.
Indian Remote Sensing Satellites, IRS, are a series of Earth observation satellites, built, launched and maintained by ISRO. The IRS series provides remote sensing services to the country. The Indian Remote Sensing Satellite System is the largest constellation of remote sensing satellites for civilian use in operation today in the world. All the satellites are placed in polar sun-synchronous orbit and provide data in a variety of spatial, spectral and temporal resolutions to enable several programs to be undertaken relevant to national development. The initial versions are composed of the 1A, B, C, D nomenclature. The later versions are named based on their area of application including OceanSat, Cartosat, ResourceSat.
Radar imaging satellites.
ISRO currently operates 2 radar imaging satellites. RISAT-1 was launched from Sriharikota Spaceport on April 26, 2012 on board a PSLV. RISAT-1 carries a C-band synthetic aperture radar, SAR, payload, operating in a multipolarization and multi-resolution mode and can provide images with coarse, fine and high spatial resolutions. India also operates a ISAT-2 which was launched in 2009 and acquired from Israel at a cost $110 million.
Other satellites.
ISRO has also launched a set of experimental geostationary satellites known as the GSAT series. Kalpana 1, ISRO's first dedicated meteorological satellite, was launched by the Polar Satellite Launch Vehicle on September 12, 2002. The satellite was originally known as METSAT-1. In February 2003 it was renamed to Kalpana 1 by the Indian Prime Minister Atal Bihari Vajpayee in memory of Kalpana Chawla, a NASA astronaut of Indian origin who perished in Space Shuttle Columbia. ISRO has also successfully launched the Indo-French satellite SARAL on February 25, 2013, 12:31 UTC. SARAL satellite with Argos and ALTI-KA is a cooperative altimetry technology mission. It is being used for monitoring the ocean's surface and sea levels. ALTI-KA will measure ocean surface topography with an accuracy of 8 mm, against 2.5 cm on average using current generation altimeters, and with a spatial resolution of 2 km.
Satellite navigation. Gagan.
The Ministry of Civil Aviation has decided to implement an indigenous satellite-based regional GPS augmentation system, also known as Space-Based Augmentation System, SBAS, as part of the Satellite-Based Communications, Navigation and Surveillance, CNS/Air Traffic Management, ATM, plan for civil aviation. The Indian SBAS system has been given an acronym GAGAN, GPS-Aided George Augmented Navigation. A national plan for satellite navigation including implementation of Technology Demonstration System, TDS, over the Indian airspace as a proof of concept has been prepared jointly by Airports Authority of India, AAI, and ISRO. TDS was successfully completed during 2007 by installing 8 Indian Reference Stations, INRESs, at 8 Indian airports and linked to the Master Control Centre, MCC, located near Bangalore. The first GAGAN navigation payload has been fabricated and it was proposed to be flown on GSAT-4 during April 2010. However, GSAT-4 was not placed in orbit as GSLV-D3 could not complete the mission. 2 more GAGAN payloads will be subsequently flown, one each on 2 geostationary satellites, GSAT-8 and GSAT-10. On May 12, 2012, ISRO announced the successful testing of its indigenous cryogenic engine for 200 seconds for its forthcoming GSLV-D5 flight.
The IRNSS series.
IRNSS is an independent regional navigation satellite system being developed by India. It is designed to provide accurate position information service to users in India as well as the region extending up to 1,500 kilometers from its boundary, which is its primary service area. IRNSS will provide 2 types of services, namely, Standard Positioning Service, SPS, and Restricted Service, RS, and is expected to provide a position accuracy of better than 20 m in the primary service area. It is an autonomous regional satellite navigation system being developed by Indian Space Research Organisation which would be under total control of Indian government. The requirement of such a navigation system is driven by the fact that access to global navigation satellite systems like GPS are not guaranteed in hostile situations. ISRO plans to launch the constellation of satellites between 2012 and 2014. ISRO on July 1, 2013, at 23:41 hours IST launched from Sriharikota the first Indian navigation satellite, the IRNSS-1A. The IRNSS-1A was launched aboard PSLV-C-22. The constellation would be comprising 7 satellites of I-1K bus each weighing around 1450 kilograms, with 3 satellites in the geostationary Earth orbit, GEO, and 4 in geosynchronous Earth orbit, GSO. The constellation would be completed around 2015. On April 4, 2014, at 17:14 hours ISRO has launched IRNSS-1B from Sriharikota, its second of 7 IRNSS series. After 19 minutes of launch, PSLV-C-24 has successfully injected into its orbit.
Human spaceflight program.
The Indian Space Research Organisation has proposed a budget of 12,400 crore, $2.1 billion, for its human spaceflight program. According to the Space Commission, which recommended the budget, an unmanned flight will be launched after 7 years of final approval and a manned mission will be launched after 7 years of funding. If realized in the stated time frame, India will become the fourth nation, after the USSR, USA and China, to successfully carry out manned missions indigenously.
Technology demonstration.
The Space Capsule Recovery Experiment, SCRE or more commonly SRE or SRE-1, is an experimental Indian spacecraft which was launched using the PSLV-C7 rocket, along with 3 other satellites. It remained in orbit for 12 days before re-entering the Earth's atmosphere and splashing down into the Bay of Bengal. The SRE-1 was designed to demonstrate the capability to recover an orbiting space capsule, and the technology for performing experiments in the microgravity conditions of an orbiting platform. It was also intended to test thermal protection, navigation, guidance, control, deceleration and flotation systems, as well as study hypersonic aerothermodynamics, management of communication blackouts, and recovery operations. ISRO also plans to launch SRE-2 and SRE-3 in the near future to test advanced re-entry technology for future manned missions.
Astronaut training and other facilities.
ISRO will set up an astronaut training center in Bangalore to prepare personnel for flights on board the crewed vehicle. The center will use simulation facilities to train the selected astronauts in rescue and recovery operations and survival in zero gravity, and will undertake studies of the radiation environment of space. ISRO will build centrifuges to prepare astronauts for the acceleration phase of the mission. It also plans to build a new launch pad to meet the target of launching a manned space mission in 7 years of funding clearance. This would be the third launch pad at the Satish Dhawan Space Center, Sriharikota.
Development of crew vehicle.
The Indian Space Research Organisation, ISRO, is working towards a maiden manned Indian space mission vehicle that can carry 3 astronauts for 7 days in a near-Earth orbit. The Indian manned spacecraft, temporarily named as Orbital Vehicle, intends to be the basis of indigenous Indian human spaceflight program. The capsule will be designed to carry 3 people, and a planned upgraded version will be equipped with a rendezvous and docking capability. In its maiden manned mission, ISRO's largely autonomous 3-ton capsule will orbit the Earth at 400 kilometers in altitude for up to 7 days with a 2-person crew on board. The crew vehicle would launch atop of ISRO's GSLV Mk2, currently under development. The GSLV Mk2 features an indigenously developed cryogenic upper stage engine. The first test of the cryogenic engine, held on April 15, 2010, failed as the cryogenic phase did not perform as expected and rocket deviated from the planned trajectory. However, the second test of the indigenous cryogenic engine was successful on January 5, 2014.
Planetary sciences and astronomy.
India's space era dawned when the first 2-stage sounding rocket was launched from Thumba in 1963. Even before this, noteworthy contributions were made by the Indian scientists in the following areas of space science research: cosmic rays and high-energy astronomy using both ground-based as well as balloon-borne experiment studies such as neutron meson monitors, Geiger-Müller particle detectors counters etc., ionospheric research using ground-based radio propagation techniques such as ionosonde, VLF-HF-VHF radio probing, a chain of magnetometer stations etc., upper atmospheric research using ground-based optical techniques such as Dobson spectrometers for measurement of total ozone content, EGLO photometers etc. Indian astronomers have been carrying out major investigations using a number of ground-based optical and radio telescopes with varying sophistication. With the advent of the Indian space program, emphasis was laid on indigenous, self-reliant and state-of-the-art development of technology for immediate practical applications in the fields of space science research activities in the country. There is a national balloon launching facility at Hyderabad jointly supported by TIFR and ISRO. This facility has been extensively used for carrying out research in high-energy, that is, X and gamma-ray, astronomy, IR astronomy, middle atmospheric trace constituents including CFCs and aerosols, ionization, electric conductivity and electric fields. The flux of secondary particles and X-ray and gamma rays of atmospheric origin produced by the interaction of the cosmic rays is very low. This low background, in the presence of which one has to detect the feeble signal from cosmic sources, is a major advantage in conducting hard X-ray observations from India. The second advantage is that many bright sources like SIG X1, Crab Nebula, Scorpius X1 and Galactic Center sources are observable from Hyderabad due to their favorable declination. With these considerations, an X-ray astronomy group was formed at TIFR in 1967 and development of an instrument with an orientable X-ray telescope for hard X-ray observations was undertaken. The first balloon flight with a new instrument was made on April 28, 1968, in which observations of Scorpius X1 were successfully carried out. In a succession of balloon flights made with this instrument between 1968 and 1974, a number of binary X-ray sources including Scorpius X1, SIG X1, HER X1 etc. and the diffuse cosmic X-ray background was studied. Many new and astrophysically important results were obtained from these observations. One of most important achievements of ISRO in this field was the discovery of 3 species of bacteria in the upper stratosphere at an altitude of between 20 to 40 kilometers. The bacteria, highly resistant to ultraviolet radiation, are not found elsewhere on Earth, leading to speculation on whether they are extraterrestrial in origin. These 3 bacteria can be considered to be extremophiles. Until then, the upper stratosphere was believed to be inhospitable because of the high doses of ultraviolet radiation. The bacteria were named as Bacillus isrinensis in recognition of ISRO's contribution in the balloon experiments, which led to its discovery. Bacillus aryabhata after India's celebrated ancient astronomer Aryabhata and Janabhakta Hoyle after the distinguished astrophysicist Fred Hoyle.
Facilities.
ISRO's headquarters is located at Antariksh Bhavan in Bangalore.
Commercial wing.
Other facilities include Balasore Rocket Launching Station, BRLS, Odisha, INSAT Master Control Facility, IMCF, Bhopal, ISRO Inertial Systems Unit, IISU, Thiruvananthapuram, Indian Regional Navigational Satellite System, IRNSS, Aerospace Command of India, ACI, Indian National Committee for Space Research, INCOSPA, Inter-University Centre for Astronomy and Astrophysics, IUCAA, Indian Department of Space, IDS, Indian Space Science Data Centre, ISSDC, Spacecraft Control Centre, SCC, Regional Remote Sensing Service Centres, RRSSC, Development and Educational Communication Unit, DECU.
Future projects.
ISRO plans to launch a number of new generation Earth observation satellites in the near future. It will also undertake the development of new launch vehicles and spacecraft. ISRO has stated that it will send unmanned missions to Mars and near-Earth objects. ISRO has planned 58 missions during 2012-17. 33 satellites missions in next 2 years and 25 launch vehicles missions thereafter, costing 20,000 crore, $3 billion. Forthcoming satellites.
Future launch vehicles. GSLV-MKIII.
GSLV-MK3 is envisaged to launch 4-ton satellite into geosynchronous transfer orbit. GSLV-MK3 is a 3-stage vehicle with a 110-ton core liquid propellant stage, L110, and a strap-on stage with 2 solid propellant motors, each with 200-ton propellant, S200. The upper stage will be cryogenic with a propellant loading of 25-ton, C25. GSLV-MKII will have a lift-off weight of about 626 ton and will be 43.43 m tall. The payload fairing will have a diameter of 5 meter and a payload volume of 100 cubic meter. GSLV Mk3 is planned to be launched in April 2014. It will weigh 640 tons at the time of liftoff, which will make it the heaviest rocket ever to be built in India.
Reusable Launch Vehicle Technology Demonstrator or LVTD.
As a first step towards realizing a two-stage-to-orbit (TSTO) fully reusable launch vehicle, a series of technology demonstration missions have been conceived. For this purpose, a Winged Reusable Launch Vehicle Technology Demonstrator (RLVTD) has been configured. The RLVTD will act as a flying test bed to evaluate various technologies, viz., hypersonic flight, autonomous landing, powered cruise flight and hypersonic flight using air-breathing propulsion. First in the series of demonstration trials is the Hypersonic Flight Experiment, HEX.
Extraterrestrial Exploration.
India's first mission beyond Earth's orbit was Chandrayaan-1. ISRO plans to follow up Chandrayaan-2 with unmanned missions to Mars, Venus and near-Earth objects such as asteroids and comets.
Lunar Exploration Program.
Chandrayaan-1 was India's first mission to the Moon. The unmanned lunar exploration mission included a lunar orbiter and an impactor called the Moon Impact Probe. India launched the spacecraft using a modified version of the PSLV on October 22, 2008 from Satish Dhawan Space Center, Sriharikota. The vehicle was successfully inserted into lunar orbit on November 8, 2008. It carried high-resolution remote sensing equipment for visible, near-infrared, and soft and hard X-ray frequencies. During its 312 days operational period, 2 years planned, it surveyed the lunar surface to produce a complete map of its chemical characteristics and three-dimensional topography. The polar regions were of special interest, as they proved to contain ice. The lunar mission carried 5 ISRO instruments and 6 instruments from other international space agencies including NASA, ESA, and the Bulgarian Aerospace Agency, which were carried free of cost. The Chandrayaan-1 became the first lunar mission to discover existence of water on the Moon. Chandrayaan-2, Sanskrit, Chandrayaan-2, will be India's second unmanned mission to the Moon. Will include an orbiter and lander rover module. Chandrayaan-2 will be launched on India's Geosynchronous Satellite Launch Vehicle, GSLV-MKII, around 2016 to 2017 timeframe. The science goals of the mission are to further improve the understanding of the origin and evolution of the Moon.
Mars Exploration.
The Indian Space Research Organisation launched its first Mars orbiter, called Mars Orbiter Mission, or Mangalyaan, on November 5, 2013. Mangalyaan carries a 15-kilogram suite of 5 science instruments to study the Martian upper atmosphere, surface features and mineralogy. It is India's first interplanetary mission and, if successful, ISRO would become the first Asian space agency to reach Mars.
Venus Exploration.
ISRO is planning a mission to Venus, by May 2015 to study its atmosphere. The probe will reach Venus by September 2015 and would carry at least 5 instruments.
Solar Exploration Program.
ISRO plans to carry out a mission to the Sun by the year 2015-16. The probe is named as Aditya-1 and will weigh about 400 kilograms. It is the first Indian space-based solar coronagraph to study solar corona in visible and near-Ia bands. Launch of the Aditya mission was planned during the high solar activity period in 2012 but was postponed to 2015 to 2016 due to the extensive work involved in the fabrication and other technical aspects. The main objectives is to study the coronal mass ejection, CME, and consequently the crucial physical parameters for space weather such as the coronal magnetic field structures, evolution of the coronal magnetic field etc. This will provide completely new information on the velocity fields and their variability in the inner corona, having an important bearing on the unsolved problem of heating of the corona would be obtained.
Space science missions.
Space Capsule Recovery Experiment 2. The main objective of SRE-2 is to realize a fully recoverable capsule and provide a platform to conduct microgravity experiments on microbiology, agriculture, powder metallurgy, etc. SRE-2 is proposed to be launched on board PSLV.
Applications.
India uses its satellites communication network, one of the largest in the world, for applications such as land management, water resources management, natural disaster forecasting, radio networking, weather forecasting, meteorological imaging and computer communication. Business, administrative services, and schemes such as the National Informatics Centre, NICNET, are direct beneficiaries of applied satellite technology. Dinshaw Mistry, on the subject of practical applications of the Indian space program, writes, "The INSAT-2 satellites also provide telephone links to remote areas. Data transmission for organizations such as the National Stock Exchange. Mobile satellite service communications for private operators, railways, and road transport. And broadcast satellite services, used by India's state-owned television agency as well as commercial television channels. India's EduSat, educational satellite, launched aboard the GSLV in 2004, was intended for adult literacy and distance learning applications in rural areas. It augmented and would eventually replace such capabilities already provided by INSAT-3B. The IRS satellites have found applications with the Indian Natural Resource Management Program, with regional remote sensing service centers in 5 Indian cities, and with remote sensing application centers in 20 Indian states that use IRS images for economic development applications. These include environmental monitoring, analyzing soil erosion and the impact of soil conservation measures, forestry management, determining land cover for wildlife sanctuaries, delineating groundwater potential zones, flood inundation mapping, drought monitoring, estimating crop acreage and deriving agricultural production estimates, fisheries monitoring, mining and geological applications such as surveying metal and mineral deposits, and urban planning. India's satellites and satellite launch vehicles have had military spin-offs. While India's 93-124-mile, 150 to 250 kilometers, range Prithvi missile is not derived from the Indian space program, the intermediate-range Agni missile is drawn from the Indian space program's SLV-3. In its early years, when headed by Vikram Sarabhai and Satish Dhawan, ISRO opposed military applications for its dual-use projects such as the SLV-3. Eventually, however, the Defense Research and Development Organization, DRDO, based missile program borrowed human resources and technology from ISRO. Missile scientist Dr. APJ Abdul Kalam, elected President of India in 2002, who had headed the SLV-3 project at ISRO, moved to DRDO to direct India's missile program. About a dozen scientists accompanied Kalam from ISRO to DRDO, where he designed the Agni missile using the SLV-3's solid fuel first stage and a liquid fuel, Prithvi missile-derived, second stage. The IRS and INSAT satellites were primarily intended and used for civilian economic applications, but they also offered military spin-offs. In 1996, New Delhi's Ministry of Defence temporarily blocked the use of IRS-1C by India's environmental and agricultural ministries in order to monitor ballistic missiles near India's borders. In 1997, the Indian Air Force's air power doctrine aspired to use space assets for surveillance and battle management. Institutions like the Indira Gandhi National Open University, IGNOU, and the Indian Institute of Technology use satellites for scholarly applications. Between 1975 and 1976, India conducted its largest sociological program using space technology, reaching 2,400 villages through video programming in local languages aimed at educational development via ATS-6 technology developed by NASA. This experiment, named Satellite Instructional Television Experiment, SITE, conducted large-scale video broadcasts resulting in significant improvement in rural education. ISRO has applied its technology to telemedicine, directly connecting patients in rural areas to medical professionals in urban locations via satellites. Since high-quality healthcare is not universally available in some of the remote areas of India, the patients in remote areas are diagnosed and analyzed by doctors in urban centers in real time via video conferencing. The patient is then advised medicine and treatment. The patient is then treated by the staff at one of the super-speciality hospitals under instructions from the doctor. Mobile telemedicine vans are also deployed to visit locations in far-flung areas and provide diagnosis and support to patients. ISRO has also helped implement India's Biodiversity Information System, completed in October 2002. Nirupa Sen details the program, based on intensive field sampling and mapping using satellite remote sensing and geospatial modeling tools. Maps have been made of vegetation cover on a 1/250,000 scale. This has been put together in a web-enabled database which links gene-level information of plant species with spatial information in a biospec database of the ecological hotspot regions, namely northeastern India, western Ghats, western Himalayas and Andaman and Nicobar Islands. This has been made possible with collaboration between the Department of Biotechnology and ISRO. The Indian IRS-P5, Cartosat-1, was equipped with high-resolution panchromatic equipment to enable it for cartographic purposes. IRS-P5, Cartosat-1, was followed by a more advanced model named IRS-P6 developed also for agricultural applications. The Cartosat-2 project, equipped with single panchromatic camera which supported scene-specific on-spot images, succeed the Cartosat-1 project.
Global cooperation.
ISRO has had the benefit of international cooperation since inception. Establishment of TERLS, conduct of Sight and Step, launches of Aryabhata, Bhaskara, Apple, IRSIA and IRSIB/satellites, manned space mission, etc. involved international cooperation. ISRO operates LUTMCC under the International Cuspar-Sarsat Program for Search and Rescue. India has established a Centre for Space Science and Technology Education in Asia and the Pacific, CSSTEAP, that is sponsored by the United Nations. India hosted the second UNESCAP Ministerial Conference on Space Applications for Sustainable Development in Asia and the Pacific in November 1999. India is a member of the United Nations Committee on the Peaceful Uses of Outer Space, Cuspar-Sarsat, International Astronautical Federation, Committee on Space Research, COSPAR, Interagency Space Debris Coordination Committee, IADC, International Space University, and the Committee on Earth Observation Satellite, CEOS. Chandrayaan-1 carried scientific payloads from NASA, ESA and the Bulgarian Space Agency. The Russian Space Agency is cooperating with India in developing the rover for Chandrayaan-2 and also in the Indian Man mission. The United States on January 24, 2011, removed several Indian government defense-related companies, including ISRO, from the so-called Entity List, in an effort to drive high-tech trade and forge closer strategic ties with India. ISRO and the Department of Space have signed formal Memorandum of Understanding agreements with a number of foreign political entities, including India carries out joint operations with foreign space agencies, such as the Indo-French Megatropics mission. On June 25, 2002 India and the European Union agreed to bilateral cooperation in the field of science and technology. A joint EU-India group of scholars was formed on November 23, 2001 to further promote joint research and development. India holds observer status at CERN while a joint India-EU Software Education and Development Centre is due at Bangalore. In the 39th Scientific Assembly of Committee on Space Research held in Mysore, the chairman of ISRO called upon international synergy in space missions in view of their prohibitive cost. He also disclosed that his organization is gearing up to meet the growing demand of service providers, security agencies, etc. in a cost-effective manner.
Logo.
ISRO's current orange and blue logo was adopted in 2002. The blue boxes form solar arrays, providing energy to a satellite depicted by a part of the orange chevron. The chevron, pointing upwards, also signifies a launch vehicle, exploring the new heights of space. The logo also renders two words spelling ISRO, on either side of the chevron, the English letters ISRO, in the Praetor font, on the right, balance the transliterated depiction of the same word in the Devanagari script. The latest issue of Space India, Journal of the organization, at the time of adoption, described the chevron as a visual representation of ISRO's upward mobility, symbolizing the organization's vanguard actions in breaking barriers both of gravity and mindsets. It goes on to say that the vibrant, dynamic and energetic logo, full of vitality, depicts the in-space ambitions and aspirations of the organization